Hello everybody. So for this video, we are going to be doing surd equations which lead to quadratic equations. Now first things first, we don't know what the heck we are supposed to be doing for this one, but we have the following. It says solve for x if the square root of 2x plus 8 minus x is equal to 0. Now this is the interesting part, right? We have something equal to 0. Is this a quadratic equation? Well, not quite. Not quite yet, I suppose. So the first thing we need to do is get rid of this stupid surd that we have. And how are we going to do that? We need to isolate it. So the first step is to isolate the square root, or whatever root you have. So we are going to add both sides by x. So we can get rid of that part over here. Okay. So therefore, what that tells us is we are going to have, geez, hectic, 2x plus 8 equals 2x. Okay. And now, what is going to happen? We need to get rid of the square root. And how do we get rid of square roots? Well, if we square both sides, right, then therefore the squares will cancel with the square roots. And why does this work? Because remember, if I say x squared, the square root of x, right, this is the same as x to the power of a half. And what happens if I take the square of both sides? Well, essentially, I'm taking the square of the square root of x, then essentially I'm saying that x to the power of a half raised to the power of 2 using the product of exponents. I can take the square in, and this is the same as what? X to the power of 2 multiplied by a half, which is the same as x to the power of 2 over 2, which is equal to x to the power of 1, which is just x. I did too much there, but hopefully that makes sense on why we square both sides. So therefore we will be left with 2x plus 8 after squaring both sides equals to x squared. Don't forget about the square on the side. Now we will be met back with a quadratic equation. So let's take everything to that side, because clearly x squared is there and it's positive, so we don't need to worry. So 0 is just going to be equal to what? X squared. We take the positive 2x over, it becomes minus 2x. Take the positive 8 over, it becomes minus 8. And now, we're going to be left with 0 is equal to, we factorize, okay? So x multiplied by x, and then we can have for 8, it'll be 2 times 4. And then it'll be what? 1 times 8. What gives us 2? Well, clearly 2 and 4 will give us 2. Because if we say 4 minus 2, we get 2. Therefore, we do our brackets as usual, and then we have x on the left side for the x times x, and then for the 2 and 4, we can put it here. But then for the operations, the negative goes to the highest, and negative multiplied by a negative will give us a positive for the remainder. And therefore, to solve for x, notice that we are going to have both the brackets being equal to 0, according to what we did in the quadratic equations, solving for x for those. So x plus 2 is equal to 0, or x minus 4 is equal to 0, okay? And this implies to us that x is equal to negative 2, or x is just equal to 4. And now this is not the final step, because it's a square root, all values in that square root need to be greater or equal to 0. Right? So let me do it in a different color. All the values within the square root need to be greater or equal to 0. Okay. So therefore, we check the value to see if it exists, to see if the equation is true. Okay. So we need to plug in an x value from one of these two to see if the final answer is indeed 0. So let's do the check. So we'll call it the check. Okay, so when x is equal to what? Negative 2. So when x equals negative 2, then what's going to happen? Then therefore, we are going to have the square root of 2 multiplied by negative 2 plus 8 minus negative 2 equals to what? We can't say equals to 0 because we need to show that it's equal to 0. So we're going to do this, right? 2 times negative 2 is equal to negative 4 plus 8. And then we have negative and a negative gives a positive. So therefore it's plus 2. And then from here, what is going to happen? Okay, I'm just going to write the equals here if that's fine. Negative 4 plus 8 is just going to be 4. So the square root of 4 is equal to 2, and 2 plus 2 is 4. Alright, so therefore, do you notice that this is not equal to 0 though? So therefore, we're going to exclude negative 2 as of now, since it doesn't give us that solution. Now we're going to try with x equals to 4. Does 4 give us that solution? So we're going to say 2 multiplied by 4 plus 8 minus 4. And then over here, we just do the simplification. It's the square root of 2 times 4, which is 8. So 8 plus 8 is 16 minus 4. And square root of 16 is equal to 4. And 4 minus 4 is equal to 0. So that is indeed true. So therefore, the final answer is just going to be x equals 4. Can you see why checking is very, very important? So that is when we can conclude that our final answer is going to be indeed x equals 4. Let's do one more example. Alrighty, so next one looks very similar, but do you notice something? They do the minus x over here equals to 0 again, but now there's also a coefficient in front of the square root. So let's do the exact same steps that we had last time. Let's isolate the square root, right? Like a solving for x question, but we isolate the square root. 3 times the square root of x plus 4 is equal to, add both sides by x, this cancels, and we have x on this side, so therefore it's equal to x, okay? But now we need to isolate the square root, and the issue is that this 3 is here, so we need to get rid of the 3. We will divide both sides by 3, okay? So therefore we're going to say divide by 3, and we also divide this by 3. So therefore we will have the square root of x plus 4 is equal to x over 3, okay? Because x divided by 3 is just the same as x over 3, okay? Now we do what we did in the last one, and we square both sides. Okay, we square both sides, and therefore from here we're going to have x plus 4 is equal to x over 3 to the power of 2. Alright, now what? What are we going to do from here? So from here we need to understand that we have a property that we need to deal with. Do you remember the property that tells us that, let me go here on this side, that tells us when we have x over y to the power of n, we can say this is x to the power of n divided by y to the power of n, where the exponent goes into both the numerator and the denominator. So we'll just apply that. So therefore, this will be x plus 4 is equal to x to the power of 2 over 3 to the power of 2, which is just 9. But I don't like that 9 in the denominator. I don't know why I took that 3 over anyway, but it's fine. We'll just multiply both sides by 9, such that the 9s will cancel, and then therefore we are left with 9x, why am I writing it in red? We'll have 9x, right, plus 9 times 4 is just going to be equal to 36. I know I could say 9 into x plus 4, but you get the point. And there will be x squared. And then therefore from here, we have positive x squared on here, so let's just take everything on that side, okay? So 0 is just equal to x squared minus 9x, because it's going to be positive 9x goes over, it's minus 9x. Positive 36 goes over as negative 36. And now from here, we solve for x, but we can't do that yet because you still need to factorize. So x squared goes into x and x. 36 can go into multiple things, such as 6 and 5. I mean, not 6 and 5, sorry, 6 and 6. And we could also get 9 and 4. So 9 and 4, we can also get that. And then one also that we can get is about 3 and 12. And then there's like, I think that is what I can get right now. But what gives us 9? We can clearly see that 6 and 6 doesn't give us 9, 9 and 4 doesn't give us 9. But notice that 12 and 3 does, because 12 minus 3 is just equal to 9. So therefore, we're going to use that. So we have x over here, and we have x here as well, close that bracket, and then 3 and 12, right? The highest one gets negative, negative and a negative gives a positive, so the positive goes to the remainder. Okay. And therefore, this implies to us that we will have x plus 3 is equal to 0, or x minus 12 equals to 0. And then x is just equal to negative 3, or x is equal to 12, right? And now we have two values of x, but we need to test that. We need to first check if this is indeed valid. If we plug in negative 3, we need to get 0 on the right hand side, or on the other side of the equal sign. And if we plug in x equals 12, we must also get 0. So let's do the check. So we say check. Okay, so when x is equal to 3, right? Is it negative 3 or 3? It's negative 3, okay? So when x is equal to negative 3, then therefore we're going to have 3 into the square root of negative 3 plus 4 minus negative 3. And we need to see if it's equal to 0, okay? So from here, it's going to be 3 into the square root of negative 3 plus 4 is just equal to 1. So therefore it's just the square root of 1. Minus 3 is positive 3, and then therefore that's just 3 times square root of 1. Square root of 1 is just 1, so it's 3 plus 3, which is equal to 6, and that's not equal to 0. Okay, so that's invalid. So let's cross out negative 3, sorry. Let's cross out negative 3. Let's check 12. Is 12 going to give us an answer that's proper? We'll find out. Let's say x equals to 12. 3 multiplied by the square root of 12, right, plus 4 minus 12, and then from here 3 into 12 plus 4 is just equal to 16, and 3 multiplied by the square root of 16 minus 12, square root of 16 is equal to 4, so it's 3 times 4 minus 12, which is obviously going to be 3 times 4, which is equal to 12, so 12 minus 12 is equal to 0, and that is true. It is indeed equal to 0. So therefore, we can conclude that x is indeed equal to 12. And let me just give you a problem that you can try on your own. Righty, and here's the question. You must solve for x if 2 multiplied by the square root of x plus 1 is equal to 20 over 2 times the square root of x plus 1. Go crazy, and a hint, it's a method from one of the previous videos. Good luck.